So you should be able to see a title screen that says getting started with NOMAD Oasis. It should be getting started with NOMAD Oasis. That's a very good start to this presentation. A nice typo on the title. Okay, let me quickly jump to the next slide, and then we can go to the agenda. So what is this about, and what is the whole tutorial about? So the idea of this 2-day event is for everyone who's interested in Nomad and the NOMAD Oasis software and wants to try this, that we give a starting point for this, right? So we want to focus a little bit on how can you install an Oasis and what is necessary to do this, and then also guide you through the first steps. What happens? Like, now I have Oasis, and now what do I do? So therefore, we have today like a little bit of theory where I just give a talk where I want to introduce the NOMAD Oasis and talk a little bit about the motivation behind it and what is necessary to install it, and then give a little bit of background into schemas and how schemas relate to data. As Claudia already motivated, right? Most of the data that we're dealing is very heterogeneous, and in order to understand what the data and the metadata means, we need to have schemas and definitions and formalize all the information that we are collecting there. Yeah, so this is for today, like a little bit of theory. And then tomorrow we will have 2 sessions, one in the morning and one in the afternoon. And this is where we want to get a little bit more practical. So in the morning, I want to demonstrate how to install this. So I will guide you through on my computer with a shell. I will basically emulate what you would be doing if you would like to install the NOMAD Oasis. Then we go through the first steps where we have a new feature that allows you to create example uploads that are predefined by us so that you get some data into your Oasis so that you have something to look at and understand a little bit the concepts. And then I will go through some of these examples. One of the examples is tailored around building an ELN. And there we will look at the schema, how you can define the schema, how you can change the schema, how you can modify the ELN and adapt it to your purposes. And then we will also look at tabular data, but it's also something that is hopefully quite interesting for many people that are used to managing the data in Excel tables and stuff like this. We have a few features there that allow you to define a schema for your table and then upload your Excel table to create entries in Nomad. Okay, without further ado, I would then jump into the talk for today. If you have questions, you can type them in the chat right away, right? And then we can later answer them. Okay, let's start with an introduction. What is the Oasis, or how did this whole Oasis thing get started? Claudia already told a lot about FAIRmat and NOMAD from like this overview perspective, and I will now turn it a little bit more into this kind of technical perspective where I will talk about schemas and stuff like this a lot. So as we already learned, like the whole journey started with the NOMAD database, like a central service, a website that you can go to and upload data. And where we now amassed like lots of theory data there. And how it internally worked is that whenever someone uploads something, right, we have all these parsers for these codes that are going through the uploaded data and trying to identify all kinds of information. And they're basically translating the raw data into a machine-readable format that has a well-defined schema behind it that is homogeneous for all of these 40 codes and for this electronic structure code kind of material science. And then on top of this machine-readable format, we can then provide all this functionality that the platform offers, like the search interface and things to visualize the data and to analyze the data. But this was basically our starting point, right? And then the idea was this NOMAD platform has a very much like a publication focus, right? It's good if you have data and if you want to publish data, you can put it there and then others can see it. But there are reasons that we will get into like in one of the next slides, that you don't want to do this right away, right? Maybe you want to start at a different point. Maybe you want to start managing your data first, right? You're not thinking about publication right away. It's your work, it's your experiments, it's your simulations. You try to figure out stuff, you try to build your workflows and so on and so forth before you actually end with the final research result that you want to publish. And then, of course, there are other reasons like large volumes of data that you have to deal with, or privacy concerns that might discourage you from using a central platform. And this is where the idea of the Oasis came from, right? So that we want to give you your own NOMAD that you can have in your own lab, in your own institute. And the idea is to shift the focus away from publishing data more towards managing data, right? So the NOMAD Oasis tries to provide functionality for the whole life cycle of the data, right? From its acquisition through analysis to refinement and augmentation until it's really publication ready. And the other aspect is, of course, that in the FAIRmat project, we want to open the platform and going away from just theory data, from just parsing input and output files of simulations, into being able to consume other data as well. And here we will see that we run into problems, or the whole schema topic becomes much more problematic, because now we are not dealing with 40 codes or something like this. Now we are dealing with individual labs, and each lab has a different workflow, applies maybe the same method, but applies it differently enough so that the same schema does not really work across laboratories and so on. So the heterogeneity of the data is much more amplified now, and that's another thing that the Oasis wants to solve, and that we will get into later in this tutorial when we talk about schemas and how to customize schemas and how to devise schemas on your own. So on this route that FAIRmat now wants to undertake, like changing the NOMAD software from running a central service to running this federated network of different NOMAD installations that we call NOMAD Oasis. We have like different steps in our plan, right? The different sets of functionality that we want to focus first, and then second, and so on, so forth. So the first topic that we want to cover is basically making the NOMAD Oasis useful for you locally, right? So if you run a lab or a group and you need something to data manage your stuff, this is what we want to focus first. And then the second step will be how can we build this network of installations where you can share data and move data between installations, where you can centralize and publish your data, and so on and so forth. And then this goes on and further integrating this network, allowing people on the central system to search for everything, so that this really becomes this one point where you go to find data in the material science realm. And then, of course, a next step could be to connect this to an even larger network that might come from the NFDI or from others at a higher level, that this connects different research databases across disciplines. Yeah, so right now we are focusing on the first point, which from our perspective means, as far as we understand our potential customers and our partners, we definitely need the support for custom schemas, because each lab is different. That's one thing that we want to cover in this tutorial. And then, of course, the ELN functionality is something that we added rather recently, where we also want to talk about in this tutorial. In the second tutorial, if you were a participant, we previewed a little bit the functionality, and now we are in this space where we say, okay, this is now like beta functionality. We can publish it to the point that you can really try this and check this out, even though this is not yet completely finalized. And of course, there are other topics that we are trying to deal with, like how can we make it easier for people to contribute parsers for new things, how to add existing file formats like the Nexus format, for example, or how to add more tools to the platform that allow you to analyze the data directly in your NOMAD installation, and so on and so forth. Yeah, in this tutorial, we will have a focus on the custom schemas and on the ELN functionality, and the other parts we have to cover in a different tutorial. But to give you a brief glimpse what this is all about, right? One aspect is like visualization. Here, for example, is a feature that we're working on where we integrate an HD5 viewer into the platform so that you can, even if you have like super large HD5 files, that you can analyze them directly from the web browser. The other idea is these remote tools where you can run applications directly in the Nomad installation. Even desktop applications like this can be Jupyter notebooks, but these can also be desktop applications and stuff like this that then run directly in the browser and give you like a direct access to your data. And then, of course, the ELN functionality is like another aspect where we think this makes it very useful for people beyond just the theoretical computational space realm. And this is what we will get into later in this tutorial. Yeah, here's the roadmap drawn out a little bit differently in alignment to the tutorial. So if you have been a participant in these tutorials, to get the story straight for you, at the very beginning, we only had like our old Nomad version that came out from before, where you could publish your theory data on the central platform. In the first tutorial, we showed like the major update of this platform with like a new search interface and which with more possibilities to manage your data and assign users different roles and so on and so forth. And then on the second tutorial, you saw this preview of the ELN functionality, and we showed a little bit what we can do with Nexus and how this remote tools thing works. There was a third tutorial on the artificial intelligence toolkit. And there we introduced like references between different data entries and workflows that you can use to capture your theory data. But of course, this is also interesting for other data as well. And now we are at this point where we have our version 1.1 in beta mode. And we want to present this here in this tutorial by showing how to install the Oasis, by showing how to deal with custom schemas and create your own ELNs. Okay, that was the rough introduction, what is going on in this tutorial and what is the aim of this tutorial. Now let's talk a little bit about the Oasis, its motivation, and then go into the technical details, like how does it work, how can we install it. Yeah, this is a slide that shows like different use cases. This is a rather old slide that was like our original thinking when FAIRmat wasn't even born. What an Oasis could be for, or why do people might want to have an Oasis? And this basically came down to these three use cases that you see here on the left. Like the first one is the academic use case, right? So imagine you are at a university, you are leading a group, and your PhD students are producing lots of theory data, for example. You might want to have something to organize the data there, so that the data doesn't really get lost all the time and so on and so forth. So that's like one use case for like having your own local copy of Nomad, right? Then of course, if the software can be installed everywhere, that also makes it easy to install mirrors and stuff like this, just for making the data availability a little bit higher. That would be the Nomad mirror use case. And then, of course, there's the idea is like if you're, let's say, you're coming from industry and you want to do stuff in private, you don't really want to let others see which data you are analyzing or what you were into and so on and so forth. Then maybe you also want to have a Oasis where it's more about like pulling data in private and then doing something with the data on your own. And then the FAIRmat idea came about, and we started thinking about experimental data and data that has a much higher volume and stuff like this. And this is where the final motivation came from. You need basically a Nomad Oasis for the two major reasons. Like one is the data volume that you're dealing with daily is just too large to put it to a central system all the time. So you have to manage it locally to some degree. And the other reason that people have, especially research institutes that deal with private funding and stuff like this, is like data privacy. They want to make sure that there's no accidental whatever leak of the data, and so forth. In principle, we can deal with the data privacy also on the central servers, of course, right? You can run, we could run a NOMAD Oasis also for you on our servers if you trust the software enough. And then it comes down to policy of the policies of various research institutes. For some, this is good enough to say the software can keep your data private even though it's run in the cloud. For others, it's not enough. Yeah. So these are the basic reasons why people want to have an Oasis. And of course, from the FAIRmat perspective, as Claudia says, we want to build this federated network to deal with the data volume and data velocity aspects of research data. And of course, this then bears the question, like if we have this network of Oasis, right? If you have an Oasis and other institutes have an Oasis, and then we have the central NOMAD maybe, how can we transfer data between them, and how does this federation actually work? Without going into too much details, because this will probably be the focus of another tutorial, the idea, of course, is that we have some unit of organizing the data. In NOMAD, these are called uploads. We will later see how this works in detail. But the idea is that these uploads are basically a bucket of raw files, of files that you manage. And then, of course, we pass these files, we normalize these files, and produce our own version of the files, the process data. So each of these uploads is basically a bunch of raw files and a bunch of process data. And in principle, we can bundle these together. We have like an internal bundle format for this, and then we can move these bundles from one installation to the other. But the question that then comes up is like, is it really feasible to move the whole upload to everywhere, or are there use cases where you only want to transfer partial data and so on and so forth? So these are basically ongoing design questions that we're asking ourselves. There are use cases where it's probably completely feasible to say, okay, this is my final version of my data. I want to upload everything. But due to volume, there are use cases where this is not possible, where we might only communicate the metadata or only communicate a part of the raw files, and so on and so forth. I think on one of Claudia's slides, you already saw this pyramid, and Claudia was also talking a lot about trash cans, right? So the idea behind this is like when you're talking about large volumes of data, that typically the research process produces this pyramid of data quality, of data value, if you want to say so. Like you start with lots and lots and lots of data, and then you throw away a lot in a refinement process, right? You analyze your data, you realize, okay, these data I can't use, these data I can use, and then you refine them more, you process them, and so on and so forth. And due to practical reasons, you might not be able to keep everything. This is why we logically divided the data into these tiers. A tier 0 would basically be data that's just too big to keep, and like there are instruments that even have to throw away data once it reaches the sensor, and then they do some processing and have to decide we can't store this because it's like petabytes and stuff like this, right? So you have this tier of local data that you will never want to be able to share, and then we go to tier 1, where you start thinking about sharing, assigning unique IDs, and want to manage the data in something like the NOMAD Oasis. And then in tier 2, we are thinking about centralizing the data so that others can also get them from a centralized repository. And with tier 3, we are thinking about like this high value data that you want to publish and accompany with your paper that has then like high demands for long-term availability and so on and so forth. So that's the philosophy behind the Oasis network, and what kind of data we want to centralize, and what data we think should be left behind. Now let me go a little bit into more technical details about the platform that are good to know when you want to get into installation issues, or also when you want to get into customizing the system, or maybe even becoming a developer of the platform. So the NOMAD software is basically built from lots of existing components. That's everything in black here. And then, of course, we build our own pieces of software that are the blue parts. I hope you can see my mouse pointer. Yeah, typically people can see my mouse pointer in Zoom. like one major component, this is what most people see, is the graphical user interface, right? When you go to our servers, you see our GUI. When you run your own Oasis, you will see the GUI of the NOMAD Oasis running in your lab on your lab. But this is not the only interface to the system that we offer, right? There's also like a Python library that allows you to access the API, and then both the GUI and the Python library using the API that is sitting below. And this is actually what you are running when you're running the NOMAD Oasis, right? You're running an app, you're running a server, and then people can use it with their browser. And as part of the server, there's lots of file management functionality, which is just based on normal file systems. And then we also run our processing pipeline, which is based on RabbitMQ, which is like a distributed task queue, which would allow you to scale up your Oasis if you like want at some point run this in the cluster, for example. The processing can be distributed. We have a Mongo database that allows us to keep track of all the processing state and all the entries that we have, so that basically keeps the administrative metadata, so to speak. Then we have all these parsers that Claudia was speaking about, the normalizers. We have Elasticsearch that deals that gives us a search index, which allows our search interface to run. And then we use, again, the file system to store all the process data. And we store this in a binary format that is called message pack. It's basically like JSON, but in the binary form. So these are the basic components. Like, and if you want to run an Oasis, this is what you kind of have to deal with, right? We need all these components to run, but we managed to package everything in a way that it's rather easy so that you can run everything without actually needing to know what's happening under the hood. But if you run into problems, it's good to know that are these databases, for example, that can be the source of the pain and so on and so forth. I don't want to, in this tutorial, I don't want to speak too much about the remote tools, but in principle, this is also something that you can run locally. This is based on Jupyter Hub, which allows to run Jupyter notebooks, but also other applications as well on the server, so that people can then use them from their web browsers and so on and so forth. We are preparing the artificial intelligence toolkit has lots of notebooks, and then we are also preparing in FAIRmat more tools that come from the experimental realm to be used. But we will present this in another day in another tutorial. Then there are a few other components that we run only in the central services. In principle, you could also do this. There's one part that allows us to deal with all the log files that are produced, that helps us to analyze problems and find bugs and so on and so forth. And the other one, and this is more important to understand for the Oasis, is our central user management system, which is based on the Keycloak software with a few plugins from us. And this user management system basically keeps track of all the users. So every time you log into Nomad, you're basically going through this Keycloak server. And we provide the Oasis in a way that you can use the same user management system that we use on the central side. This makes it much easier for us later to get into this federated idea to transfer data when basically the user is the same on each installation. So we recommend people to install the Oasis in a way that they are basically reusing our central user management system, even though we also offer the option to have basically your own user management system if you need this. Yeah, here's basically the same picture with a little bit of different paint from another perspective. This would be more like the thing before was more like the software overview, which components does our software have. This is like more the architectural overview, like what kind of apps and servers and stuff like this is running in the system. Again, it's repeating itself a little bit. I don't want to go into too much details, but it is important to know that when you run the NOMAD Oasis, you're basically running 4 to 5 different containers. You will be running an Elasticsearch, you will be running a MongoDB, you will be running a RabbitMQ. This is all standard software that comes with standard images that can be run rather easily. And then we provide our own services. These are the blue boxes here. also as containerized applications. So there's one image for the NOMAD software, and then you will basically run 3 different components from them. That would be the app first, which serves the GUI, which serves the API, which contains our documentation and so on and so forth. And also a part that is called the worker. And these are basically processes that are pick up on all the necessary work that has to be done, that do all the parsing and normalizing and so on and so forth. And then later, when we are ready with the Node tools and you also install your Node tools, this will be another part of the application where you have to run the Jupyter Hub, so to speak. Yeah, so these are basically the components, and everything is containerized. So we use Docker for this. We provide Docker images, and for the installation, we provide Docker Compose scripts, which make it rather easy. So all the configuration is already contained. You can just download the configuration, adapt it a little bit, and then you can start the NOMAD Oasis. And tomorrow morning, I will show you the easy steps to follow so that you can see how to do this and what are the typical problems that you might run into and so on and so forth. What might also be interesting is like how we actually organize the software itself. We have a GitLab that is running at the Max Planck Computing Facility in Garching that we're using to hosting most of the software. Some of the software is also on GitHub on our organization there. There's a GitHub organization called NOMAD COE. There we host, for example, all the parser code and so on and so forth. Yeah, and what this GitLab is doing for us, besides managing our source code, is that this runs a continuous integration and continuous deployment pipeline. So there are automated processes every time a developer is doing a commit and making a change. We are producing a new Docker image, basically a new version is released that you can then use and install or update your Oasis with. So there might be these scenarios, especially with our close partners, where some of us on our side are developing stuff on a specific branch, and that you might want to run them locally as part of your Oasis. And then it becomes important to understand how our branching system works and how these images are tagged and versioned and so on and so forth. So we will also go into this a little bit later. And then the Python package that people can use is then also published to PyPy. I think a very straightforward process for typical Python packages. Normal way of distributing Python packages this way. Yeah, this is what I wanted to say for the general overview about how the technical details of the NOMAD platform look like. Now I have 2 more slides that go into the installation itself. What kind of machine do you need, and what are the requirements? That would be the first slide here. The short answer is there is no real requirements, right? Because it really depends on what you want to do with the NOMAD Oasis. Our general recommendation is like you don't need much to run this to just get started. So just to get started, just find the Linux box, use your laptop, whatever. For example, to follow the tutorial tomorrow, there isn't much need, right? A few gigs of RAM, a few CPU cores are enough to basically just run the NOMAD Oasis. If you want to use this then productively and actually manage data for your group, for your institute, or even for a larger space, then of course you have to think about how to scale everything. And when it comes to things like storage, the answer I think is pretty easy, because basically what NOMAD does is managing files, right? So we are just keeping your files. There is this processing that looks at the files and is extracting metadata and so on. But typically in comparison to the raw files that you provide, the size is rather marginal, right? So the storage requirement solely depend on how much data do you have or anticipate to have and want to manage. The computational requirements, it's a little bit more complicated. This depends a little bit on how much data do you need to process. So for example, if you want to run just an ELN where human users are inputting information, it's probably not a big concern. If you're uploading like tons and tons of high throughput calculations, then this might become more problematic and you have to scale accordingly. But there is no real advice that we can give in the beginning, but start with some server, test for yourself what works for you, and then scale respectively. With the memory, it's like it's similar. When we process data, the different worker processes that are running and processing stuff at the same, for parsing one individual database entry, they will try to keep all the metadata in memory. And for super large simulations, that can be a lot, but typically it's not really a problem. Like if you have a normal size computer and the relationship between the number of CPU cores and the number of RAM you have is somewhat reasonable, then that should also be fine. Okay, so there's no much real stuff I can say about the technical requirements, just a little bit of background information and some thoughts to go through.
There's a question in the chat about this.
Yeah, I can open the chat, but I would prefer to answer it after the talk, if this is okay with the question asker.
Sure, we can wait.
Yeah. Yeah, okay, now that I read it, the question is about the internet bandwidth as a requirement, right? There are various ways to deal with this. Like if you think about data uploads, like the normal way of uploading data would go through our API. Basically you would need to have the network bandwidth to put it through the API, but with typical with typical institutes and how they run their IT, typically the network isn't the bottleneck. It's more like the speed of the file system that is beneath the installation. So I'm not really sure if this is like a huge concern. But there are ways of allowing local uploads. Like let's say you already have the data on the file system in your institute that is connected to the server. There are ways to tell the API, I don't want to upload the data. The data is already there, and this is the path where you can find it. Okay, the installation process itself, we try to make it as simple as possible. There are different ways of installing this. You can do the bare metal, I just know Linux and I want to run everything manual if you want to. We don't recommend this. Then there's the Docker way. This is the way that we would recommend, and that is then tomorrow part of the tutorial, which makes it pretty easy because yeah, everything is in containers, and there is this Docker Compose that allows you to run a lot of containers in a pre-configured way. So that would be like a single node installation that we are demonstrating there, and which is probably adequate for most people in the beginning. There is also a way of installing the software in Kubernetes clusters. This is what we do for our central system. It's not very well documented at the moment, but if a partner of ours or someone is interested in it, you can ask us about it. And it's typically not too hard to translate the Docker Compose into a respective Kubernetes configuration. So in principle, the system can be scaled to clusters and so on. Yeah, I guess there isn't much to say for me right now. Tomorrow we will really look at the configuration files that are necessary and talk a little bit about the details and problems that might arise. Maybe one word about the versioning. As I said, we have this continuous integration that is running. So we are producing new images daily, so to speak. And in order to figure out what is the right image for me, we use tags on these images, and they typically follow version numbers with semantic versioning. So let's say you have version 1.0.3 installed. Updating to version 1.0.8 is not a problem. Upgrading to version 1.1 should also not be a problem. Upgrading to version 2 might be a problem, right? Because this major version change typically means that we change something in our database layout or whatnot. So we don't really hope that we need to do these kinds of things frequently, but if they occur, you have to be careful. And this is basically what the version numbers are about. And otherwise, they are very important for us to communicate. In version 1.1, you have these features, and version 1.1, you might not have these features. Tomorrow in the tutorial, we want to give a preview for version 1.1, where we simplified the installation process quite a bit. And this is basically our current beta version that we want you to try and figure out. Then there are also these latest and stable tags, of course. And then there are also branch names. Like every time a developer creates a branch on our GitLab and is committing something, there's an image built, and this image has the branch name as a tag. And this might be important if you are collaborating with us or if you become a developer yourself and whatnot. Okay, the rest I think we will see tomorrow when we really look and start this for ourselves. And this would be it for the installation part. So I think I've already been talking for half an hour. I will have a few more slides on data and data schemas. I will try to increase a little bit in pace. If you are a frequent visitors of us, of FAIRmat, of FAIRmat talks, and so on and so forth, you might know some of the stuff already. So let me go through it a little bit more quicker. There are principal ways of how data gets into our system. The way that is talked about the most is through parsers, right? Where you have computer simulations, for example, that produce data in certain file formats, and then we have parsers that allow us to understand these formats and translate everything into our own metadata format. But now we also want to offer other ways, right? For example, we want to have this ELN functionality, which allows people through human activity to actually enter the data manually, right? And do the experiments and take notes and write these notes down into NOMAD directly, for example. That would be like a completely new route. And then there's this other thing that we want to talk about. This is tabular data. For some reason you have legacy data, or this is just how your lab works, right? Lots of people are managing data in Excel files and stuff like this. This could also be a way to introduce data to the system. And this does not necessarily have to be manual tabular data, right? CSV files and so on are also often export formats of tools, of other databases, and so on and so forth. For parsers, the schema idea is pretty simple, right? We write a schema that defines what the information is that the parser is basically finding and filling out. For the GUI, the schema has the functionality of, it has to provide the space where people can express themselves. It has to set the limits and the boundaries, the borders, right? What are the form fields? What are the information that people have to provide, that they can provide, and how does this information need to be structured? And then for the last part, for the mapping part, the schema is also very important because this is then all about mapping, right? If you want to import something from a different database, what was the schema on this side? What is the schema on the NOMAD side? How can we translate the data? Yeah, to give you an idea, or to make it easier for you to think in these realms of schemas and data and what is the difference, you have to imagine the whole data management thing as a 3-storied building. In the cellar or on the first floor, whatever you want to call it. We have the actual things that are producing the data, like we have real life phenomena that we want to measure with our sensors, or we have computer simulations that run stuff. This is where the data comes from, right? And in the second story, we have the actual data. We store it somehow in files, and we have data formats and databases and whatnot. But logically, we are here speaking about data in terms of bits and bytes, numbers, and so on and so forth. And typically, we distinguish between metadata and data, where the data is more like the actual information. Typically, these are, I don't know, matrices, pixels, numbers. And then there's the metadata that describes what these pixels, matrices, and numbers actually mean. Who acquired them, where they acquired, what was the environment, like these kind of things. But also, how was the experiment prepared? What are the settings, and so on and so forth? How does this embed into a workflow? And then also like normal stuff, like when you have numbers, for example, right? What is the scale? What are the dimensions? What are the units, and these kind of things? And then on the third floor, we have the schemas, and schemas. The job of the schema is basically to define what is the possible data structure, what are the possible metadata, what are the possible data, and what form do they have. And this is what we want to look into now. I don't want to go through all the text. This is you can look at the text yourself when you the slides are shared on the tutorial webpage. I just want to look at the example here. I want to distinguish it a little bit again between schema and data, and show you a little bit of the problems that you have. Like, it sounds pretty easy in the beginning. Yeah, you have the schema, you have the data, but it can very soon become very, very confusing, because what typically happens is you have a schema and stuff have a name, and you have data and stuff has a name, and it's very often the same name. And then, yeah, you get a knot in your head and so on and so forth. So let's look at the right side first of the example, like here where we have the schema. I typically try to talk about the schema in terms of definitions, like the schema defines stuff. So in NOMAD, we like to call the data blocks that we have sections, like a section is like a block of related information. And in the schema, we might do something like define a section A. And then we say this section A leaves space for quantities for certain subsections, right? So for example, I want to say in section A, I can have a quantity Q, and this quantity has a type, right? Q can be a string, and it is a shape. Like in this example, I say it's just a scalar, so it's just one value, right? So the section A can have a quantity Q that is of type string and that can take one value. But this is basically what this definition is saying. Then in the second line, it says, okay, I also want to have a subsection, which basically creates a relationship between my section here and another section. I want to have a subsection S, and the section that is used by the subsection is supposed to be another section. Like here in this example, you see another quantity. I also called the Q here, but this time it's a float, and this time it has a different shape, a 3x3 matrix, and so on and so forth. So what these definitions are basically giving me is the framework, right? There is nothing about data in there yet. It's just saying what shape the data can take. And then on the data level, we would then really talk about the actual information. So instead of a section definition, we would deal with a section instance of the definition A. And we would say, okay, this Q now gets a value, right? And the subsection S also gets a value. There's another section, an instance of section B. And then here we have this other Q, which now also gets a value, the 3x3 matrix. Here just a few numbers for example. Yeah, so when you want to think about schemas and stuff like this, it always makes sense to really clearly think about definitions and clearly think about instances. Otherwise, it becomes very quickly very confusing. You see, there's a queue and there's a queue, and when you want to reason about what queue is and you want to talk to other people, you have to be very clear whether you mean the definition of queue or whether you mean a concrete value of queue and so on. Okay, that was my bit of introduction to schemas, what they are. You already saw that in NOMAD we try to organize everything in sections, like having these building blocks for information, and these sections can have relationships, and the key relationships are the children relationship and the normal reference or cross-reference or whatever relationship. So in NOMAD, you can build these hierarchies through subsections. You just saw it in the example. One section can define another section as a subsection. For example, here, you could have a section for sample information, and then this has subsections for the processes that are applied to the sample, for example, or the characterizations, measurements, whatever that are done with the example. You could organize this as children, right? The other form of relationships would be references. Let's say you have a section chemical defined, which allows you to express chemical information, or to store information about instruments and so on and so forth. Those might be completely unrelated, stored in a different database, stored somewhere else in the Oasis or whatnot, but you still might want to do these kind of reference relationships where you say, okay, this process uses certain chemicals or uses a certain instrument. And then maybe the instrument itself also has subsections that talk about the maintenance of the instrument and so on. The key with these relationships is that the children relationship is much closer. It's much restricted, so to speak. Like one section can only have one parent, for example, and these children relationships form these three hierarchies. And this is what NOMAD database entries are mostly about. We use these hierarchical data structures to display data. So if you have used NOMAD before, you probably came across our browser where you can go through the data in this hierarchical fashion. So this is a very close relationship where you will see stuff together, right? You will look at your sample, you will immediately see the processes. And then there's also the possibility to have different entries in NOMAD. You can have one entry that has this whole hierarchy in it. And then you can have other entries to deal with the chemicals, for example. And this you can use to design your ELN a little bit, right? Where you can say, okay, I define one schema where I control all my chemicals. I have another schema where I control all my instruments, and then different people might fill out these schema data sheets that you created, so that you have a database for instruments, a database for chemicals, and so on and so forth. And then when you create samples, you can then cross-reference and use this. Okay, this is the most scariest slide that I have today. There's lots of information in it. I wanted to make this more approachable, but it's always like happens to me that I end up wanting to put all the information in it that is relevant for a certain topic. So what I want to show here is like how data gets into NOMAD and how it's processed. And there are different ways of doing this, and they are somewhat important to understand why do I need a schema, and if I have a schema, where do I put it, and what does it mean? If you look at the blue stuff, this is basically what the old NOMAD was doing before we started with FAIRmat. It had the schema information basically hard coded into the software itself. Like we were writing down the schema as Python classes directly into the system, and then this would be part of the NOMAD software. This is what the filled out means, right? Everything that's filled out is basically part of the NOMAD software, which means if you install the NOMAD software, you can't really change it unless you become a developer and change the NOMAD software itself. So this is like the limitation with these hard-coded schemas that we had before. They were good enough for the parsers, right? For all the simulations data that you upload and put into the system. But there's no way to really customize these without changing the software. And this is where the idea came in, that we wanted to have these custom schemas, these uploadable schemas. And this is the route that you see here. So let's say you're not a NOMAD developer, you're now a user of NOMAD, and you want to customize an existing schema or create your own schema. You need a way to do this. And this is also what we want to see, look at tomorrow, how to create these YAML files to have your own schema, because this then makes the Oasis useful for you, even if you are not familiar with these parsers and you're not a theorist and you're not really caring about the computational data. You want to have this for an ELN, for example. Then this basically allows you to define a schema, put it into the system, and then make it available for other users in your Oasis. So this is what we will look at tomorrow and also in the next slides in more detail. And then there are other things that you can do. For example, there's this whole Nexus thing that we are working on, again, another tutorial. And then there are different ways, depending on these schemas, how to enter data. For example, the NOMAD ELN, this is what we want to talk about in this tutorial. Let's say you have a schema like this, right? Then you can use the NOMAD ELN to create data in NOMAD, and then they are passed according to this schema that you provided, and then they end up in the system in our database according to the schema that you have provided through this route. Yeah, I don't want to explain this chart in more detail, but if once you understand this, it gives you like lots of information about what you can do in terms of what kind of file can I upload and what does it mean. Yeah. This is interesting when you want to provide your own schemas in terms of Python code. So if you want to be more involved into the NOMAD ecosystem and want to become somewhat like a developer, right? NOMAD is an open platform, and we would accept contribution from everyone who has like a meaningful contribution. So for example, people that are writing parsers, for those people, this is interesting. So if you want to write a parser and the schema that we already have is not enough because you are into a new method or your parser is doing something that we don't yet have in the system, you might need to extend the existing schema or program your own schema. And this is basically the old schema interface that we had. You had to write them down in Python. So you were basically writing simple Python classes. So each section would basically be a Python class. Like here, I define a section run, a section system, a section calculation, and then in these sections you could define various properties of these sections. So, for example, you could say the section run has subsections, and then you could say the system is one subsection, the method is one subsection, the calculation is one subsection. And in the section system, for example, we define lots of quantities where you say, okay, I have atom labels. Like these atom labels, they are strings from an enum, so they're taken from a list of available chemical symbols, right? And then they have a shape, and the shape is the length of the number of atoms that are set here as an integer, and so on and so forth. You can use your imagination here. You can use these simple functions to create your own schema. And once you have written this down, you can also use it in Python, right? Since these are just Python classes, you can deal with them like you would normally do with Python classes. You can just instantiate them. So for example, you can say, I want to create a system, and then I want to fill out the data quantities in my system with something, right? So the parser might get the unit cell from somewhere, and then create lattice vectors from them and put them in there. Or you, let's say later on, you also created a calculation and you want to fill out the reference right here in calculation system reference. We define a reference from the section calculation into the section system, right? You can fill it like this. Or when you want to set these subsections, you can do something like this. Like the section run was defining subsections for system and calculations. And then the system that we created here, the calculation that we created here, we're simply adding here as subsections to these subsection definitions here. So this is like how parser development works. I won't go into more detail. You will get links to documentation stuff like this where you can read about like how to provide a parser, but this will not be the focus of the tutorial. Yeah, and then later on, once you created data like this, you can also use the Python interface to actually do something with the data. So that's an interesting for data analysis. We have artificial intelligence notebook toolkit notebooks that are demonstrating this as well. So there is a Python library that we provide that you can use to query for data, and then you get it in the same way as we created it here, and then you can read it, right? So this is like the writing data, and this is the reading of data. Okay, this is like the old school way how we used to do things, and now there's a new feature in version 1.1, and this is like the custom schema, or the possibility for you to provide schema through uploads. So we can't really allow people to upload their Python code because, like, security-wise, especially on a central system, that would be a no-go. We can't just take your Python code and execute it in our processing where you would have access to everything. So we devised a different way, and this is, you can describe your schema, and you can do this in JSON or YAML. YAML is typically more convenient to write, and then your YAML documents could look like this. So like this is a simple example. Tomorrow we go into more details about this, how you would write down your schema. But it's the same thing as before, right? You're basically saying, okay, this is, I want to write down some definitions. First, I want to write down some sections, and then you're writing down some sections. Like here, I create a section element. And then I define the quantities for elements. Let's say an element has an order number, which is an integer. It has a symbol, which is a string, for example. Or I say I want to have a subsection, and then I define what the subsection is. I call this subsection properties and say it has also quantities, like the density of the element, the melting point, whatever. Typical stuff that you find on a periodic table, for example. So you can simply write them down and then upload them. And then you can also create an ELN from them. And how we do this, we will see tomorrow in the tutorial. And with data, it's the same thing. Also, data can be written down as JSON or YAML. It's a very similar structure. Now it's not a schema. Now it's actually data. And then we say, based on what schema is this, right? So if we put this in the same file, we can even upload the schema and data in the same file. If this would be in the same file, this definition here would basically say, okay, I want to make my data based on the schema element, on the schema section element here, right? So this here. So I'm basically saying the system, the data section now has the shape of whatever is defined in the section definition. And then you find the order number, the symbol, and the properties, and so on and so forth, right here. Like the order number int is an integer, the symbol here is a string, and so on and so forth. And then, of course, the data has to match with your schema. That's the whole idea. And then once you upload this to NOMAD, the NOMAD parser will check whether everything is in order. And then you can preview the data in NOMAD and can see everything. Everything there, and later on when you publish the data and so on and so forth, people would know what symbol actually means because it would be related to the schema. And this is like very basic here, but in the schema you could write down a human description, for example, and say what the symbol means, provide links to, I don't know, Wikipedia pages or whatever, to provide more context. But more specifically, people would see, like, see for density, for example, what the unit is to make sense of the number. Yeah, so this is a new feature that you can provide schema and data in this way. And this is almost my last slide. Another thing that you can do with schemas is, as I tried to say in the beginning, the purpose of the schema is to define data structure and what possible data looks like. But there are other aspects of data that are also important for the system. For example, we want to make decisions on how the data is presented, how the data can be added, how the data is to be plotted, how the data should be managed, and so on and so forth. There are other aspects of data management that are related to schema definitions, even though they're not really part of the schema itself. And this is where we are talking about annotations. So we basically allow people to put annotations into the schema, and then various elements of the system of NOMAD, of the NOMAD software, are picking up on these annotations depending on what they are and what they want to do. So for example, we have an annotation about ELNs, which gives our user interface information on what form field to use when people are supposed to edit this. So here in this example, I define a quantity storage and I say it's of type enum, and then I provide a few enum values. And then with this annotation, I can basically enable the ELN functionality and make this editable. And then the GUI would not just show the value, it would actually provide me with a form field, and it would use this component, which would allow you to choose from the edit values through a drop-down menu, through a pull-down menu, and so on and so forth. And we have like lots of these annotations that control various aspects. There's an annotation that you can use for plotting data, and then there's annotations that enable certain features in the browser, and so on and so forth. And tomorrow we will see a few examples of those and how to use them. Okay, that brings me to the end of this talk. It was a little bit dry. It was lots of information that I just poured into you. I put these slides on the homepage of the tutorial, and I think it could be a good reference for tomorrow, when you maybe, after I showed you how to do stuff, you try to do it yourself. That you can have a look at this stuff. Otherwise, let's have a few questions, and then I close with a few remarks on the program tomorrow. So if you have any questions, it's the same as before. Write them in the chat, or just raise your hand. And I try to look at the chat because I ignored it for the rest of the talk. There's something in there. Yeah, Markus Kübach has a remark, right, about how we are doing things in FAIRmat and how the FAIRmat people could work together with interested parties that want to run the Oasis. So in FAIRmat gives us the possibility to have lots of people that are not just developing the software in like with their eyes closed, right? But we are really interested to cooperate with Interest Institute. So if you are someone who wants to run the NOMAD Oasis and maybe have a pilot project for some of your lab or whatever, we can put you together with what we call domain experts. Like we have people from area A, B, C that we say are domain experts that know what the platform is, how NOMAD works, and they also are somewhat experts in their respective fields for certain experimental methods or whatnot. And the idea is that those people work together with you in helping you to devise the schema, to write the schema, yeah. And we use this as a mechanism to get feedback as well, right? So the NOMAD platform, and especially these new features, it's all quite new, and we need people actually who want to try this, and we want to have close cooperation and communication with you. So please do not just try the Oasis behind closed doors and for yourself. Talk to us about it. We might be of help and assistance there. We have an active interest in actually helping you, because this helps us learn about what the typical problems are, what possible features for the future are, and so on and so forth. Yeah, Sasha, you raised your hand.
So I'm working here at the University of Warwick in England, and we had a Oasis test installation. I think about a year ago it was installed, and it hasn't been updated yet. And it cannot use Docker because the admins don't allow it.
I think I remember the case, yes. Mm-hmm.
Yeah. So first thing, should it be updated?
Yeah, it really depends on what functionality you want to have, right? I think we did this. I think it was by James initiated somehow.
Yeah, James did it. I had nothing to do with the installation itself. So but I'm the one who wants to get updated on this, and who's getting this information. And I just want to ask if what's the status on that?
Yeah. So this one is a really old one. This is like our old version 0. And from version 0 to version 1, there were really some major changes here, even in the database layout. So if you have some data that you want to keep, you would really need to go through some migration steps. So that would be somewhat painful, I would say. Then I would guess it could be rather easy, but we don't really pay super much attention to these bare Linux installs, right? So there might be some problems that you run into, like when we test stuff and we focus on the Docker installation.
Sure.
Yeah. Yeah, it might be reasonable to upgrade to version 1.0, where like lots of the stuff got improved. The parsers are much better now, and yeah.
Okay. All right, thanks.
There's a technical question from Andreas. The data is integrated via file system. So in practice, one would do NFS or bind mounts into the container. Yeah, exactly. That is what the basic installation would do, right? So the Docker Compose, the out-of-the-box Docker Compose files that we provide you with, they just use bind mounts to create like one directory that we call .volumes, and then everything is in there. When you want to integrate this in a larger structure, you can do whatever is possible and necessary to like mount stuff in there. So that could be file systems that come from somewhere else that are, I don't know, attached storage or whatever. This then really depends on your infrastructure, but we trust that the Docker ecosystem is like flexible enough to hopefully fulfill most people's need. From the software side, we just need to have like a regular POSIX whatever file system to work with. Rachel, I learned I have to ask you to unmute. I have to find the button, but maybe Lucia can do it for me quicker than I can do it.
Hello, can you hear me?
Hi.
Hi. So I have a question. So I'm from Johnson Matthey Technology Center in England. And so we are actually very interested in NOMAD Oasis for the modeling part of the research and development. And currently, so there is another ELN that the experimentalists use. So this is from Dotmatics. I don't know, most probably you're aware or not, it doesn't matter. But my question is, how can we link NOMAD Oasis to the other ELN so we can kind of work together? Is that easy to do? Or, I mean, yeah, how can we approach that problem? Because basically we have we have two different solutions, right? And I know that NOMAD is trying to incorporate also experimental data. I mean, in a process and going in that direction, but it's mainly done now for theoretical and DFT data and any kind of computational data really. And on the other hand, we have this other ELN in-house now, which is dealing mainly with the experimental side of things. And it's a little bit tricky. And for us in terms of DFT group, I mean, it's obviously NOMAD Oasis makes much more sense because it offers the tools that we currently need, and we want to go towards this kind of change.
I don't have anything in my pocket that I can give you that would work out of the box, right? So we of course we are thinking about other ELNs, and we would even encourage people to use other ELNs when they are tailored for what they are doing, right? So if, for example, in the FAIRmat project, there are people that are using this ChemMotion, which is like very designed for chemistry processes and stuff like this, where it's then much better tailored for them than whatever we could offer, right? And so the idea really is to use ELNs, not just go for NOMAD. We just wanted to provide like an easy way for people that don't have something like this, because in the solid state physics realm there isn't necessarily something for you. What we discourage people to do is to use ELNs that are just note-taking tools, right? Because they won't really allow you to structure your data, right? When it's just about like writing documents online and describing everything in a rich text editor, This is then where the FAIRmat philosophy we don't really see fulfilled. This is also one of the reasons why we get started. We looked into stuff like Elan FTW, for example, and we found it interesting, and it's very popular, and we want to support it and stuff like this. But the possibilities that you have in order to structure your data are quite limited in platforms like this. The stuff that we're actually working on is like there will be an Elan FAW integration at some point. So this is something, for example, that's directly worked on. I haven't heard of your lab notebook variety, but this is just a matter of like finding someone who's interested, who knows the system, and who's willing to provide an integration. It's the same as parser developers, right? Where we're also looking into you have this interesting code. Maybe you want to develop a parser for NOMAD. So if you want to go there, we can definitely support you or help you in trying to integrate the systems. Again, what we said about domain experts, right? Someone of us could have a meeting with you and look into this other ELN and what kind of API it has and what other ways of getting data out and in and stuff like this. And maybe we can enable you to actually provide to create your own integration. And then we would, of course, ideally, you will contribute this to the overall ecosystem so that others might also benefit from that.
Okay, sounds good. Thank you.
Yep. Jonas is asking, when using the central user management, is there a way to restrict user access to an Oasis? Yes, exactly. So what you're suggesting, the whitelist, is exactly what's in there. You could re-ask the question tomorrow, then I could show you in the config file where to put it. So there's basically a config parameter where you can just set a list of email addresses from NOMAD accounts. And then only those people can access the Oasis. So if you provide a whitelist and you go to the Oasis, you would immediately be asked for login, and then only those people that are in the whitelist can actually log in. So that's a very convenient way to have your Oasis in the public, but still restrict the access to the overall thing. Otherwise, what others are doing is, of course, you can run the Oasis in a VPN. The Oasis does not necessarily, the Oasis server needs to be able to talk to the internet, but the internet does not have to be able to talk back to it, so to speak. So you can run your Oasis behind a VPN or whatever, or in a private network. And that's also a possibility to restrict the outside access to the Oasis rather effectively, I would say.